Hello. So some people tells me that they quote my video. They quote my video before and saying why I hate Rust programming language and in so-called carbon language, and other people are telling me. So I would like to watch the video about how about the language, whatever. I just watch the video, okay. I haven't watched it either. I want to hear what they're saying.
All right. It's good to be back at a conference. This is very strange for me. It's been like 2 years and I haven't done this, so if it's a bit rusty, I apologize. It's my fault, it's all my fault. But I'm really excited to be here. I am incredibly excited to be here. My name's Chandler. I do lots of C++ things. But today I have an interesting talk. This is not really the title of the talk, though. The real title of the talk is a question. C++. What comes next? A bunch of you think that you know the answer. I don't actually know the answer. This is the answer. I don't know. And this talk is going to try and dig into why we don't know and what we can do about this, because I think this is actually a question we should have an answer to. When I say what comes next, right, we've had a lot of other programming languages that have gone through transitions over the years, right?
Well, this kind of untrue, right? C transits to C++? I don't think so. I mean, there's still a lot of good reason to write C. Why do you think C is transitioning to C++? Well, the idea is that we have a new language that could just kill the old language, whatever, that kind of mentality. JavaScript and TypeScript, so are you saying that TypeScript people are now using more TypeScript than JavaScript? Now Objective-C and Swift, but Swift is also killed, right? Nobody is using Swift either. You're not transitioning. You're actually killing both of the market, or Objective-C to Swift. Java to Kotlin. Kotlin, it's more like a Android-specific language. It's not actually replacing Java in any form, right? So what are you talking about, right?
When we come down to C++, we have these question marks, and I have no idea what needs to go into these question marks. So how do we answer this question? How do you even make progress on answering this question? Well, I like to go back to our goals. I always like to start with our goals, or what problem we're trying to solve when we're talking about what comes next. What is it that we actually want to do with C++? Titus and I gave a great talk, and Titus even referenced it yesterday. It's almost like we talk a lot about what C++ is, and we try to really dig into our goals for C++. I'm not going to try and go into.
So that is basically mean the goal of C++ for Google, right? That's the only thing I was saying. To be honest, I don't care about all they are doing at all, right? I do Canadian compilation. Do you care about Canadian compilation at all? No, right? No, those people probably don't even know this is a Canadian compilation. I'm sure Chandler probably knows because he's the lead dev of LVM, but no.
Into as much detail. It's a fun talk if you want to watch it. But at the highest level, our goals for C++ are performance-critical software and language evolution, code that's easy to read, understand, and write, practical safety and testing, like fast and scalable development, have to support all the modern operating systems, hardware, different environments. We wrote these up in a paper for the C++ Standards Committee years ago. This isn't new. And these are still our goals today. But the problem we're trying to solve is that C++ is still falling short of these goals. It's not doing as well as we would like. Now, I can get up here and give you a million examples of why. You probably already have your own ideas in your head of where it is that you think C++ falls short. Titus gave a talk yesterday talking about places where C++ falls short. My question is, why? Why is C++ falling short of whatever goals we have for it? What's the root cause? And I think that the initial root cause is that C++ has been accumulating just decades of technical debt. Right? It started off with decades of technical debt when it inherited the debt of C. We got textual preprocessing, we got absolutely bizarre operator overloading rules and precedence rules. We've gotten integer promotions. I mean, we can go on and on and on. There was a tremendous amount of technical debt that no one wanted to change. And it wasn't like C++ made a mistake. This was not a mistake. This was an excellent decision to take on this technical debt. It was expensive, but it was probably the right call. By inheriting all of C, C++ actually bootstrapped its entire ecosystem. This was essential to its success, especially at the time. C++ then coupled this with one other decision that I think is the part of the root cause of this, and that is prioritizing backwards compatibility. And this has caused C++ to continuously add more technical debt to the language. I mean, we put co underscore in front of all of our keywords because we are terrified of breaking existing code. And understandably, breaking code is actually really expensive. It's really disruptive. Backwards compatibility is a huge feature, but it also is very expensive. And it's not just that we add new technical debt. Backwards compatibility prevents us from fixing the technical debt we already have. So we started off with C's technical debt. We continually add more, and we have a priority that means we can't.
Yeah, right. Linux kernel isn't writing C++, right? And I talked about for a very long time why C++ was a very terrible idea for writing operating system. So they are saying C++ has replaced C. It's just a false claim, right? Neither, like he said, Kotlin has replaced Java. It'd be ridiculous if you tell them, hey, Kotlin has replaced Java. Google said that. Well, it'd be ridiculous, completely ridiculous, right? Okay, I'll put the chat here, but I want to just go. Hey, can I just put only this part? I'm not gonna see your chat.
Really fix any of it. This is not a recipe for success, okay? And I think this is the root cause for C++'s technical debt and a lot of the other problems that C++ faces today. Unfortunately, there's another factor that compounds it, and that's the process by which C++ has evolved. And this process is something very constrained, right? C++ is part of ISO. ISO has very, very strict rules about how things work. And it's interesting to think about what motivates the rules of ISO. Like, what is ISO trying to achieve with these rules? ISO is trying to achieve representation of nations and corporations in the establishing of standards. That's a perfectly reasonable goal. And I actually think ISO's process is pretty reasonable to achieve that goal. If that's your goal, ISO makes some sense. But I think it's a very different goal from making complex design decisions to address complicated technical problems like the technical debt that is currently all over the C++ programming language. If you want a group of people to do that, I would not prioritize representation of nations and corporations. I would prioritize psychological safety and a really effective team with some really good experts that has a good decision-making process, that can move fast and quickly evaluate different options, right? That would have a way to experiment. All of these things make sense, but they don't make sense for ISO, and because C++ is part of ISO, they're not really available. I think that makes all of this much more difficult to fix within C++. So this is kind of a downer. What are our options? Well, there are a bunch of really great programming languages out there. Tons of them. Unfortunately, most of them are garbage collected. And to be fair, garbage collected languages are kind of amazing. They're wonderful. They're simple languages, they just work, they don't have a lot of the complexities of other programming languages. You can easily use them and they do the right thing. They're safe, they're reliable, but they have some performance cost, right? You pay for that. You pay for that simplicity, that ease with the performance overhead. And for many users, that's a great trade-off. You should absolutely make it. If you can afford to spend a little bit of your compute resources on using a garbage collected language, that's fantastic, right? But some of us can't. There are some users who really need every single bit of the performance that C++ affords us. So these aren't good options there. Of course, a bunch of people would say, Rust, it's Rust. I hate to break it to you all, this is not a Rust talk, just for the record. But Rust seems like it might fit here. It's really, really interesting language. But if you look at the other languages on this, right, from C++ to TypeScript, Swift, and Kotlin, Rust doesn't actually fit really well. That's actually not anything about Rust. Rust is a great programming language. And again, if Rust actually solves your problem, if it's a good tool for you to use, please use it. It's a fantastic programming language. I'm super impressed by everything.
Look, he's super impressed by Rust programming language, dude. Everything about Rust is good. He's basically saying, when using that language could easily break entire of your system. They can just easily block you, right? They have the political decisions. They hate United States. They hate Russia. They not hate Russia. They also hate China, right? These all great superpowers in the world. They hate all of them. This is what little Rust folks are doing, right? They're basically just liberals. They're a bunch of liberals, right? I don't even trust them from political decisions. They can easily block you, right? How do you say it works for me for today? Not mentioning all the bloat and all the problems with it. So it's not working, right? It's not working at all. How do you say, hey, Rust is fantastic? You're wrong, dude.
That the Rust community and the Rust team are doing. But if you have a very large C++ ecosystem, and you have very deep dependencies on it, moving that to Rust is going to be extremely difficult.
No. That is not the reason I don't use Rust. Okay, Rust is just a bad language. That's the reason. It's not moving to. It's ridiculous. These people making this completely ridiculous claim. Then telling you, hey, it's some ecosystem problem that you don't move to Rust.
Okay, so if Rust isn't going to work, and garbage collected languages aren't working, what other approaches do we have? Let's dig a little bit more deeply into these historical languages. So C to C++, JavaScript to TypeScript, both of these are really interesting. These are kind of superset languages. Both C++ and TypeScript took the entire existing thing. You can just map it into the new language, no problem at all. Swift changed it up a little bit. Swift is a kind of brand new language, but it had an interoperability bridge into Objective-C. Also had a bunch of other confusing things that complicate things. Swift is kind of a different beast. But it started to explore a different way to move from one language ecosystem to another. And I think Kotlin's really nailed this idea. Because here we have a new language, right? It doesn't try and include all of Java. But Java feels natural. It fits. You can take your Java code, use it in Kotlin, and it doesn't feel like you're, really bending over backwards to try and make it work. It's not contorted. It fits very naturally. And you can even turn that around. You can use Kotlin code from Java, right? It's a really, really seamless interoperability story that allows Kotlin to build on the Java ecosystem without including all of Java and making itself a superset. So I think this is a super interesting pattern. And there's a common thread for each one of these languages. And that's that each one was designed for the purpose. Each one of these languages was very intentional when it was being designed that they wanted to build on top of an existing ecosystem. Right? They didn't want to start a new one. And I try to call these successor languages. Right? When we talk about a successor language, we build on an existing ecosystem, provide bidirectional interoperability, optimize the learning curve and the adoption path, and I think ideally you should have tool-assisted migration support. And when you put these together, you have a pretty compelling way to introduce a new language that builds on top of an existing one. And this isn't even a new idea. If any of this sounds super familiar, it should. Herb talked about this at ACCU. He gave this exact same analogy. Now, his talk focused on the superset case. Because when you're a superset, your compatibility, your interoperability, it's perfect, right? It's just perfect by being a superset. I'm a little bit more interested in the Kotlin design, which isn't a superset, and it doesn't have as perfect of interoperability, but has a different freedom. It gets to make more sweeping changes. It gets to make more dramatic improvements. I think that's really compelling.
That's the problem of those language people, right? I mean, those are problems with language people. They don't care about real world situations. They just creating languages all their hand. Hey, this is the reason. That is the reason, right? Oh, you're talking about I'm you right. I well, these people are literally just guessing reasons, guessing why that is this and that is that. Because they believe we're language developers. We're writing compilers, yeah, and we know what the other people want to do. No, right? If that's the case, why the game developers don't want to use all your standard library, don't want to use all of the things? Even I don't want to use those things. No, you don't care, right? You don't even care about anything about operating system kernel. You just think, hey, A, B, C, D, this is the reason, that is the reason. You don't even know the reason, right? Then you're saying, hey, one X, Y, Z has failed.
But we don't have one of these that fits in these question marks. This doesn't exist. There's not a good language today that I can fit into those question marks that takes this successor language approach in order to be a compelling option for current C++ users. And a few of us thought, this is really too interesting to leave this way. This is something...
I'm sorry, despite I haven't used the language, I don't even know anything about the language. To be honest, even the Hello World example of this Carbon programming language, I just see the Hello World example, and I don't like that language at all. I think the language is repeating the mistake of when Rust was a failure. Why a similar language is like, oh, right. Anytime you and these people, these language people, they try to add something, they'll just, hey, we want a format string. And the only thing gonna do, right? A format string, right? Format string. Just everything they know is format string, nothing else.
We need to explore. So we started building something that would fit into these. We're calling it the Carbon language. The idea is an experimental successor to C++. Okay, so how...
Well, Rust also claimed that, right? Rust even claimed that you should never use C and C++, neither C nor C++ anymore. If you use them, you are violating human rights, right? You're violating human rights. That's literally the attitude of Rust was saying. Right? They said it's an successor to C and C++, right? Now you're saying another language is doing the same thing. This Google's one is Carbon language. Microsoft also had their own one, right? Microsoft has this Project Verona. Instead of fixing anything, they just, hey, we add this, we add that. We just create a new language, because it's whatever. Create a new language because whatever. They don't actually addressing any issue with the C++. He's saying, and I know what he's complaining about. He complains about things like, still unique pattern. It has ABI issue. We cannot break it. But why do we have that kind of issues in the first place? Is that actually because of backwards compatibility issue? No, it's just simply because people who design those features, like smart pointers, are designing poor features. Smart pointers are bad features. That's the reason. It's just bad feature. Then people come back, hey, this causes it.
How does this work? How do we have an experimental successor? We take the goals that we have for C++, like the original 6 goals, but now we have to add a critical 7th goal: interoperability and migration from existing C++ code. Right? We have to tie back to the existing ecosystem. And there are 3 things here that I think are going to really allow Carbon to address the things that have made C++ really
I think I need to jump a little bit faster.
That's the interoperability,
because it's
migration,
just, I'm not interested in our language or evolution at all. I have no interest on how the language is going to evolve at all. They don't even evolve to a better place, right? If you think of C+17 file system, is that actually evolving or just degrading? No, I don't want to care about how the evolution of the language.
To the parser. If you've ever worked on an IDE for C++ or something that doesn't get to really be a full compiler, it's incredibly difficult. We can make that better. But that's not enough. If we just have one step function, that's not enough. We need something better than that. We actually need to sustain these improvements. And so we need a language evolution model. And I specifically think we need one that isn't focused on backwards compatibility and is instead using tool-based upgrades as the language improves. Continuous tool-based upgrades as the language improves. If we combine these, I think we have a really compelling option here. So let's dive into what this would look like if we were to pull these together and what kinds of things you could expect. First thing, I think we just have to clean up the grammar. I don't know if anyone's worked on a C++ parser, but it's miserable. If you've ever worked on an IDE for C++ or something that doesn't get to really be a full compiler, it's incredibly difficult. We can make that better by simplifying the grammar and making it easy to parse. This doesn't take a lot of wild new technology. We can just use introducer keywords. So here we use a keyword fn to introduce a function. Use the var keyword to introduce a variable declaration. And with this variable declaration, we get to fix something really phenomenal, right? I don't know if you all realize this. On Wikipedia, the most vexing parse, there's no qualifier for language, the most vexing parse is a C++ parse, right? And that's just not okay, right? But we can fix this. We know how to fix this and build a grammar that's friendly to humans and also friendly to the parser. We can keep going, so we can use the name and then a colon and then the type and a pretty standard structure here. And this also is easier to parse. This also is much easier for the compiler to handle, but it's also good for humans. Humans like this kind of syntax. I also think we can have...
Human like this syntax? I mean, maybe. I just said maybe. You cannot just saying everyone is liking it. I find quite ridiculous they make that kind of argument and say human likes this, likes that, right? Or to represent other people. Like I say, everyone loves format string, right? If you don't have format string, you're wrong. You don't even have a standard to say that. How do you even make that kind of claim?
Really phenomenal, right? I don't know if you all realize this. On Wikipedia, the just and also parse to address. We actually have already seen these, right? We have a circle input here and a log2scale input. And these kinds of function parameters are the ones that in C++ you have this really frustrating...
Well, if I remember correctly, Rust is using very similar syntax here. Right, if my memory was correct. So Rust is an... So Carbon is the successor to C++, but Rust is not? Okay.
Choice to make every time you use one. You're like, well, I can use a const reference and I won't have any copies that I didn't want, which is nice, that's good, but it won't pass it in register, which is a little unfortunate if it's a 32-bit integer. Or I can use by value, which is great, it'll pass it in register, it's really efficient, but it'll also force a copy, and sometimes that could be really expensive. And if you're writing generic code, then you just don't have any good options, right? Because you have to pick one of them, and you know that there are these other types for which it's not the right answer. But the language can address this. We can just provide a tool that very directly addresses this and expresses the intent. We can even make it short and easy to write. We can unify all of our indirect and mutation access around pointers, collapsing all of the references and the 3 or 4 different kinds of references into a single part of the type system. And pointers are fundamentally simpler than other things because you can actually refer to the pointer separately from the pointee, something you can't really do with other constructs. And we actually are using this here too. We have an input-output parameter, a results vector, right? And we pass this as a pointer. That means that down here, we actually use pointers to indirectly update our caller's results vector. We can also use expressions to name types. I don't know if you've used C++'s templates in Anger a little bit, but there's this whole other grammar for how to name types in C++. There's some exciting parsing problems within it. It can be really, really frustrating. We don't need a second grammar here. We can reuse the expression grammar. And we're actually, again, already doing this. We have circle, and this is just an expression. It references a global circle, and we have I32. This is also an expression. It's kind of actually like the expression 32. This is a literal that gives you a type. And we have something more interesting. If we have a parameterized type, like C++'s std vector, right, we can actually use function call syntax for that to say this is a vector of 32-bit floating point types. Make sense? Another place we can simplify is the global namespace. I don't know if folks have worked on large code bases, but like at Google, we spent about a decade doing really terrible things in the global namespace because there was no guardrail in the language to stop us. It was so easy to put things into it, and then ODR and other chaos ensues. We don't have to have that kind of problem. We can actually make sure that the namespace at the root of your files is always local, so we make it local to a package of source code. And so when you start your file off, you immediately say, this is a package and its name is geometry. And now, right? And so when we, at this point, no one is really fond of me. I suspect that whole language evolution thing is gonna get pretty easy to understand. We just tried to simplify and focus, and nothing too remarkable here. It's like making, we use impl, and it's in a consistent position. Virtual works basically the way you would expect. Nothing. Extended any further. Of course, final classes can still extend other classes. We can use keywords to make this a little bit more readable. We also try to clean up other keywords, so there's just an abstract keyword to mark abstract methods.
Oh yeah, that's literally what they want. They want to just introducing this abstract interface. Just extends. This is literally using the Java's technique, right? Literally Java's technique. The problem is that, you know, the Hubstarter has its own meta class thing, right? What you can do with that? Meta classes allow you to just even extend the grammar manually, but your stuff don't, right? You just put in the compiler. Because what you want is basically an old language. That's the only thing you want, right? But I don't care about O at all, so why bother?
Something with the summary interface said so. Screen. Once you do this, I have a geometry namespace, right? We said when we parse all the C++ code as C++ code, no fancy other thing going on there, and we build a C++ header module out of it. Once we have the C++ header module, we can look at that AST, and we can walk over it and synthesize a Carbon AST that maps into it. And then that's the thing we actually import semantically, okay? And so this is how we build that interrupt bridge. And the compiler handles all of the messy parts, and you get this really simple model where if you want some C++ code, you just import the library. There's no problem at all. And now we have cpp.circle. Again, we have this package rule in Carbon, and we kind of...
Has anyone knows how it's going to work with micros? How micros is going to work with here? I don't know.
Put C++ within that to have a nice clean state. So it's a cpp.circle here. We can get an object of it. We can get it members of it. It's the C++ object. There's not any overhead here. We're just completely representing the C++ object for you inside of Carbon. But that's only one direction. We can do the other direction as well. So we can have some C++ code, and it's just normal looking C++ code. But it's going to include a header file that looks very strange, right? Because we didn't write this header file. This is a synthetic header file. And so when Clang, again, comes along and it sees you're including this, Carbon header file thing, it's like, hold on. I know about this because there's a Carbon module over here, right? And it goes and it loads up that Carbon module, takes that AST, walks over it, and synthesizes a C++ AST that will map back into the Carbon one. And then it imports that as a Clang header module. Right? And because we have modules in Clang that can just transparently take the place of header files, this can actually work, and it can be very intuitive and very clean. Okay? And once you do this, I have a geometry namespace, right? We said that packages were always in their namespace, so this is geometry. And then I have a print area function.
Oh yeah. I have to piece up the syntax, right? You have the syntax here. Then you have this zero thing, right? Zero. You have this format string here. Then, okay. So I don't know how it's going to work for GCC. Are they going to make that work for GCC, or this only works for Clang? If it only works for Clang, it doesn't work for GCC and Micro's MSVC, then it's not going to achieve anything, right? It's not going to achieve anything. I'm sorry to say that, but you are not achieving anything here.
And I can just call it. We can even provide a bunch of implicit conversions with low tech, make decisions with it. And the thing is, this is a great group of people, but we really need to go further. So
look, he said those are great group of people. Those people are problems, right? Those people are problems. I'm sorry to say that. People in this list are problems, right? No jokes at all. You are problems, right? Your problems. You are the one who making the freestanding so bad and saying, hey, C++ would replace C. Whatever nonsense. Complete nonsense, right?
Our current goals and focus, number one, going public. Hi, everybody. You know, this method right now, this should work. You can load up Carbon. We have some sample code in.
I would like to see the binary side. Could anyone just see how large a hello world example would be for this? I believe the binary size will be very large. That's my belief here. It's probably very large.
In Carbon, and it compiles. Okay, I'll refresh this just to make sure this is actually working. And if I have a typo here of what comes next for C++. My goal to have kind of, I mean, my goal isn't really to compete. My goal is to try and explore, things that we aren't able to do with C++. And so I don't think C++ 23 or 26 or 30 or 40 are going to completely change the grammar or introduce a novel generic system. And so in some ways, I think we're really trying to explore alternatives that aren't available in a kind of backwards compatibility prioritizing world.
Backwards compatibility, but it only works for Clang. The binary string large. You have tried that? How large it is? I believe it will be very large because those format string thing will be very large, right? They have to put entire runtime in it, pour entire runtime. It's not like fast.io, right? Fast.io would just, it never introduced any real runtime here, right? It doesn't use format string at all. It doesn't pour dead code. But this format string approach will always pour dead code.
See, like I already see some of the Carbon features are already coming.
Much safety as something like Go or Swift has, if not all of the concurrency safety that Rust is able to provide.
Right, he's saying Rust is better than all those languages now. Right, this is the only thing he has to say about that.
Hey, awesome effort and awesome initiative. Congratulations! Like it really looks really good. And I'm, to be honest, I'm excited to see where all this goes. It's just the start, and thanks for sharing that with us. I appreciate it. A quick question. Any thoughts about the tooling ecosystem? Can we reuse tools that were built for C++, like Clang Analyze, things like that, that work on the AST in the Clang and things like that?
Do you have thoughts?
I think probably not directly. A lot of those tools are very tied into the exact representation of the Clang AST. It may
Now he's saying it's tied to the. This one would, I guess this one would fall to the same fate. You know, well, that's my thought, because they're saying we are 100% compatible with existing C++ code, right? Whatever they're claiming, but they only works for Clang AST. He said, right? He only works for Clang AST because it's working in just to manipulate the Clang AST, right? Then I just use another language to generate the same AST here. It will only work for Clang. It doesn't work for GCC. No, I don't. I don't prefer Clang to GCC. In fact, if you look at the building process, you always need to build GCC first before building Clang. Right? You need GCC as the prerequisite to build Clang. Particularly you're doing Canadian compilation, like I'm doing those compilers, like this Clang is doing. It's compiled from GCC on Linux, cross-compiled from GCC on Linux, even on Windows Linux. So Clang is always, you always need to compile Clang with GCC. Then how do you think prefer Clang to GCC? It's an alternative. It's an alternative for compiling my code. I can just test them and pick a better one. But Clang cannot actually replace GCC. Neither will be better than GCC. No.
may be possible that there is some way that we can reuse those or extend them to work on a combined Carbon C++ program.
Awesome, thank you.
Hello, thanks for presenting, Chandler. That was really quite exciting. I've got lots of questions. I think the first question, though, is that C++ has no reflection story. Do you intend to have one in Carbon? And if so, it seems to me that's going to create some significant interoperability barriers. Any thoughts?
I think we've been thinking about reflection a lot and metaprogramming a lot, but I don't know that we have a concrete plan in place. That said, I don't think it's going to create too many interoperability barriers, because if you're doing metaprogramming in Carbon, you're kind of going to, at the end, produce something that still exists in the Carbon world and semantic model. If you're doing metaprogramming in C++, you're going to do something that exists in the C++ world and semantic model. And so if we have good interoperability between those two semantic models, we should be able to have interoperability even between metaprogrammed semantic models within those worlds. And the whole idea of using a genuine C++ frontend to kind of parse the C++ code should let us run the C++ metaprograms kind of faithfully as they would have in C++. And so I'm not massively worried about that. I mean, I think migration might be a bigger challenge there, because metaprogramming is a huge barrier to kind of tool-based transformation of code. So I would be much more worried about things like migration than interoperability when it comes to metaprogramming.
No, he's not addressing any issue, to be honest, right? He's still talking about, hey, it's just migration issue, instead of talking about other problem. Ross also said that, right? It's only because you have legacy code that we don't use Rust. No, right? No, that's not the case.
Thank you.
So in your slide, it was mentioned that there is a CLA. So who do you sign the CLA to?
It's a great question. Right now, we're bootstrapping with Google CLA, but the plan from Google is to basically, as soon as there's a foundation that makes sense, an independent foundation, we'll transfer everything over to that foundation. We're following the same model that Kubernetes and a few other major open source initiatives have followed. Or they have to start with some entity holding the CLA, and then once there's kind of an independent foundation, they transfer things over to it.
Because
from different representations. And so we can have an optional pointer for null, right? And we can have some kind of slice type or range type for the thing you actually can index and increment.
So the pointer is going to be non-null by default, and if you say optional depointer, then...
It's kind of funny, right? I don't even want to listen to anything. You just talk about Nuperta. They don't talking about anything useful, just talking about Nuperta. Just nothing, right? Just literally talking about nothing. Just talking about the same bullshit, modern C++ bullshit times and times again. Instead of addressing the issue, hey, why freestanding C++ doesn't work?
You get a nullable pointer.
Yeah.
A stable ABI that would be used in the case where you actually want a hard ABI boundary and you want to be able to have two pieces moving past each other and separately compiled, which we are hoping is going to be a rare case.
How we can interop with that, it's a more difficult interop problem, but we are. I mean, I don't think it's that. It's either epochs or tool-based upgrades, right? Tool-based upgrades of C, but adding a small talk-like set of language features. And then Swift has again done another level of successor after that.
Okay.
I can't think of another one.
Thank you.
Well, on a slightly different scale, different versions of languages behave like incremental successor languages in a lot of ways.
Yeah.
Can you tell us anything about what you're doing to make the community a healthy environment?
Yeah. I mean, so the first thing we're trying to do is we have a code of conduct in place. We're actually trying to uphold it really, really carefully. We're trying to give really clear, just kind of heads up to people joining the Discord to try and set the tone there. We want it to be a super.
Oh yeah, they just banned me, right? Because I disagree with the decision, right?
Compiler.
Just shit. I don't want to watch it anymore. You can, if you want to watch, you can go watch it. I think this talk is super problematic, right? It's super problematic, making a lot of false claims in this talk. I don't care about slicing things. No. I just think their goal was not. They're probably not going to achieve the goal they are trying to achieve. The reason I use C++ rather than a lot of other languages is that there's no options at all, right? There's no option. They don't actually provide any options. I'm saying I want a Canadian compile programs. I want to create cross-compile a compiler on Linux that works on Windows. Then the work compiler would work on DOS, for example. Your stuff only works for Clam. It doesn't work for GCC. How do you really being out? How is that even really an alternative? Well, it's compared to Rust, it's probably gonna have better interoperability issue. But if you try to if you're not using LLVM torch and you're using GCC, you're in deep trouble, right?
That, right, like at the extreme, that's also sort
benevolent.
That's fair. But I guess the question is like, are there any ideas for what time frames look like for what's
So let's just end the video. I just ended streaming. I don't want to just stream it anymore. It's just complete waste of time. I think I waste my 50 minutes of my life just for doing so. That's the thing I would like to say. I'm not interested in this at all. I think there's nothing. But I want to see some conclusion. I want to see something conclusion is that now you have another language that competes with Rust, right? Microsoft have their own Project Verona. Now you Google have this Carbon language. Just everyone is creating their own so-called C++ alternative, whatever they think it is. Well, what ends up is that those languages will just fight each other. Those languages will kill each other finally. I guess that's what's going to happen. Because none of these languages can actually replace another one. Right? So they just fight each other. I believe the human rights language would be, the community would be very unhappy with it. They always complain about this and that. I compete with, it's actually doing that, right? It tries to just compete with Rust. Right? It's literally what the language is doing. Right? Just in another form. That every language, every you know, just all these big companies just doing so, right? They just, hey, we don't like this, we just create another one. Then these languages, you find that I am in this ecosystem, I'm gonna work on another one. Just like today we have C# versus Java issue. Now you have Project Verona, you have Rust, you have this Carbon, you have other languages. Don't forget, we also have Zeek, V, right? Or that kind of language. Those languages are gonna fight each other, and finally you realize none of them are fixing issues, right? They don't fix anything. It's just one more language. It just recreate the wheel in general. Sure, you have this Grammarly. I think their thing is that we have this syntactically, we can just modify the client EST to interpret with C++ better. But still, it ties to compile, specific compile. It ties to client. It doesn't work for GCC. It doesn't work for MSVC, right? So it's, I mean, if this language is going to succeed, it's probably in the way that it only works for Google. Google gonna rewrite something with their legacy code base with this language, right? But rewrite some part of this, write this, and write that. Like writing some part of Chromium with this. But you're not. But then you have. Well, I think they just introduced more problems, and I think they're solving the wrong problem. They think that C++ is that way, but probably not, right? Probably not, because you cannot even say C++ is for the highest performance language, whatever. He's saying that C++ performance critical. I doubt it. I mean, I doubt it just always for performance critical software. Right? If you compare to assembly, C++ code runs extremely slow if you don't know how to do the thing here. It runs very slow. Even you are not the problem. The compiler might screw up, right? So to say C++ is performance critical software, that is Google's goal. Probably that's how Google is using the language. And also, do you think that Google's code is very easy to read, understand, or write? No, right? Of course not. Just Google's code is clear not easy to read, understand, or write in any form, right? Of course, it's gonna in C. Practical safety testing. I don't even test. I don't even test. So that is not absolutely a goal. In fact, C program doesn't even test either, right? I think C program don't like tests at all, right? Fast and scalable development. Do you think so? I mean, I doubt it. I mean, C++ never say that. It's probably what you're saying. Modern OS platforms. But I care about legacy OS platforms, right? I care about DOS. You don't care about that, but I care about that, right? The Pentagon, the US military, the White House, they care about Windows 95, right? Are you gonna say, hey, Mr. Pentagon, let's just throw all your computers, all your machines into garbage, right? They'll fight you, right? They probably have very important data on fighting terrorism, fighting Al-Qaeda. You're saying we don't support that. We don't support modern operating system. Right? Just, I mean, different people use the language for different reasons. Not like you saying it's performance critical. It's probably how the Google is using the language. Doesn't mean it's how other people are using it, right? The entire talk is just trying to push their own worldview on other people, even that is probably untrue, right? I think that's the major problem with the video. I don't think how about comment. Yeah. Pentagon still running Windows 95, and still run, and even DOS is still running in a lot of, probably DOS runs more than the Windows 95 because DOS is a very good embedded system nowadays. They run in the factories, they run in the machines. Running the factories, running DOS is a very good option, right? It has very low consumption, but it can manipulate the hardware very well. Yeah, but those people are thinking, oh, only the new things are important. They don't even think anything about how we're gonna support the legacy Windows 95, all those hardware, right? If you don't, then C will the thing C++. No, that's exactly one reason why C++ won't replace C, is that C has a lot of support to those legacy systems, right? Than C++, and much better. Right? If you want to try to targeting those platforms, you have to rewrite the code in C. Unless you are like I'm doing, I'm trying to, saying I try to make my code more portable, right? Avoid all the modern C++ garbage. But they are saying, hey, I'm troll, right? They're saying, I'm troll to not using sto-move. I'm troll to not using sto-vector, right? Okay. That's it. Do you have any other questions I can answer you here? If you don't, I just stop streaming. You can ask me on Discord, okay?